It's not so much that we're building our cars in a way that they would be safe to put a human in them. You would not want to ride in one of our cars, right? But what we're doing is creating the platform to test technology, to find those failure modes, to find those edge cases. And from that, then take that learning and transition it into the commercial world. And if we can come back to them and say, hey, your LiDAR worked great, but the quality breaks down at 120 miles an hour, then they can look at making improvements or tuning the vehicles differently.
Today, I'm joined by Paul Mitchell, the president of the Indy Autonomous Challenge, a program where universities compete to build the best and fastest AI race car, some reaching speeds of over 150 miles an hour. Originally a $1 million prize competition, it has evolved into a worldwide series of challenges that encourages college students to push the bounds of math, science, and design. Paul Mitchell has always had his sights set on the best ways to get industry, government, and academia working together. And it was with this drive for collaboration and innovation that inspired the Indy Autonomous Challenge. We live in a time where design and technology touch every aspect of our lives. But where did it all come from? Who designed it? How was it built and brought to market? What will it look like in a year, 2 years, 100 years? From the phones and smartwatches that help us in our day-to-day to the cutting-edge spaceships and 3D printers that are leading us into the future, modern design is constantly shaping the way we work, communicate, problem solve, and play. And every new design, big or small, starts with an idea and a bill of materials. I'm Magenta Strongheart, and this is The Bomb, where we talk to leading innovators in the tech world and celebrate the transformational power of design. Here's my interview with Paul. Welcome to The Bomb, Paul. Thank you so much for taking the time today. I'm really excited to learn more about the Indy Autonomous Challenge. So maybe we can just start there, and you can tell us a little bit more about what it is and how it got started for our listeners.
Sure. Well, glad to be on. So Indy Autonomous Challenge is a competition among leading research university teams to program and create artificial intelligent drivers that compete in fully autonomous race cars at speeds that top out at around 180 miles an hour at racetracks across the United States and soon overseas in Europe. It started out as a prize competition. So we had the idea that if we could build autonomous race cars, we could attract the best and brightest minds to develop the AI drivers for those cars. And so we put out a call to kind of the top universities in the US saying, we'll offer $1 million prize to the team that can develop this software and win an initial race that we scheduled at the Indianapolis Motor Speedway in October 2021. And it worked. We got 31 or some odd universities to sign up for the challenge. And in the end, we had, I think, maybe 20 universities that made up 9 different teams that competed in the first event, and we gave out that $1 million prize. And from there, we realized there was something more to this. It shouldn't just be a one-off, but instead we should continue to push the boundaries of autonomous vehicle technology with additional events, additional competitions, and that's where we are now.
Some aspects that I'm super curious about when it comes to autonomous technology, autonomous vehicle technology, is the kind of policy and legality that's going to go along with it as it progresses and as it becomes more accessible, more, consumer facing and that sort of thing, and mainstream. So I am curious, how you see, if you've seen, what developments, if any, as far as policy evolving or changing, or, government stakeholders paying attention to these technological advancements, and are they moving quick enough? My guess is no, but I'm curious, if there's maybe some key players that are paying attention and, seeing what's coming, or is it going to be, kind of up to each private company to have their own, legal coverage and liability and whatnot as these things become more mainstream?
Yeah, I think we're still very much in the Wild West kind of formation of ideas and policies and approaches. And I don't think that there's a clear model yet for how autonomous vehicles are going to be, financed, owned, insured, operated, the liabilities, the safety implications universally across the U.S., European, Asian markets. I think that's a ways off. What I'm seeing is that there is no shortage of interest and attention and investment from industry, academia, and government. So a lot of the headlines, are about autonomous vehicle car companies, startups, or even larger organizations, whether it's Tesla or Waymo or Cruise, and all the billions of dollars they're investing. And some people are critical. What do we have to show for it yet? Why isn't this happening faster? There's also billions of dollars being invested by governments around the world in the infrastructure and the technology that's going to be needed for autonomous vehicles. There's R&D grants, there's pilot programs. A number of state governments in the U.S. have been really progressive. I think Indiana is one of them, but Texas, Arizona, Florida, and others in creating rules and regulations that allow these operations to start on public roads, which I think has been good for the industry. So I think, it's going to take a while for there to be kind of a one size fits all approach. At least in the United States, you're seeing a lot of the action at the state levels. Individual states are opening
Taking
up and
the
saying,
initiative.
and I think America's kind of got a history of the states being kind of a laboratory to try things out. Some California will do something, or Texas will do something, and then people learn from it. But our focus with Indy Autonomous Challenge is trying to advance high-speed automation. So we do feel that there was a lot of momentum and a lot of investment and a lot of focus on low-speed urban, suburban, robo-taxi type of use case. And that was what came out of the DARPA Grand Challenge, and that was what most of the companies were building their strategies and their investments and fundraising around. And we've seen a shift somewhat toward on-highway trucking, and a number of the big companies that are active in autonomous, said, okay, maybe we need to be focused on trucking even more so than the robo-taxi. But even with that shift, I don't feel there's been enough testing, validation, focus on, can the autonomous systems handle high-speed operations? And by high speed, I mean maybe above 100 miles an hour, right? If you think about the value of an autonomous vehicle in saving lives, if it can operate safely at 100 miles an hour or more on highways and not have the kind of accidents that human drivers have at those speeds, and keep people safe, then that would get us from point A to point B faster. It would mean that commerce could move more quickly. So, and of course, if they can operate at 100 miles an hour, they certainly can operate at 70 miles an hour. So I think for us, we wanted to create a platform where we could really test out and validate the effectiveness of high-speed automation. And we feel like that's filling a gap that maybe the industry hasn't been addressing.
Right. That makes sense. And so I've understood that something that's really important to what you guys are trying to tackle is the safety side of things, of course, because that's going to lead to, like you said, it being effective and being kind of proven out. So what are you guys doing on the technology side that is focused on making sure this is happening safely and that the new technology is advancing in the most safe way possible?
So I think what we're providing through Indy Autonomous Challenge currently is really a test platform in which you can take the cutting edge hardware and software that the commercial industry is bringing to market. So our sponsors and the technology on our race cars are the same technology that's on current autonomous vehicles that are operating around the world. So our LiDARs come from Luminar, our radars are going to be coming from Continental. We have a computer from D-Space, communication systems from Cisco, and so on and so forth. Cloud computing, data analytics from AWS. So our ability to get that technology and put it into the form factor of a race car that can travel at these high speeds, and then to test it out at racetracks is unique. And then on top of that, what we're doing is each team is like a different OEM. So each team has developed their own software, their own AI driver, the way Google has Waymo's AI driver or Tesla has its AI driver. So we're actually creating an environment in which these different AI drivers are having high speed encounters with one another. So it'd be like taking not just 5 Waymo vehicles and having them go really fast, but taking a Waymo vehicle and a Tesla vehicle and a Cruise vehicle and having them all encounter each other in an environment in which they're being told to pass or overtake. And if one does something dangerous, seeing how that car reacts to the other one. So in that sense, what are we doing to advance, safety? It's not so much that we're building our cars in a way that they would be safe to put a human in them. You would not want to ride in one of our cars, right? But what we're doing is creating the platform to test technology to find those failure modes, to find those edge cases, and from that then take that learning and transition it into the commercial world. And that's why having these sponsors that are building and selling these products into the industry, if we can come back to them and say, hey, your LiDAR worked great, but we're seeing something that the quality breaks down at 120 miles an hour under these conditions, then they can look at making improvements or tuning the vehicles differently. And then from our teams, if they can develop a software driver that can react the way a human race car driver can to a high speed encounter, that part of the decision making and path planning and that part of the code could be put into, let's say, a more standardized, robust AI driver that's handling urban suburban routes. But when it gets onto the highway, it's informed by these kind of really high skilled decision making algorithms for high speed encounters.
That is a perfect segue to my next question, which is who owns the code from these competitions? When it comes to, the university students, the university, the sponsors, your organization, how does that work?
It depends a little bit on like which part of the code and which part of the technology we're talking about. So the code that what I refer to as the AI driver, the kind of the driver that lives on the central computer system and is taking all the information from the ADAS system and making decisions, is owned by the teams. Some of those teams have arrangements with their universities where the IP is owned by an independent lab or a spin-out company, and they can commercialize it through that. Other teams, it's absolutely owned by the university itself, and some teams are very focused on just the research, and they're trying to take whatever learnings they have and just share them with the world in a more open source type of approach. I think the Technical University of Munich has an approach where they're very pro open source. I don't know that they're releasing absolutely everything that they develop, but a lot of the software, a lot of the algorithms that they develop for Indy Autonomous Challenge, they're putting on GitHub, they're sharing with the broader community. So it depends on it depends on the individual team, how they want to approach it. And then there's other IP, right? So there's improvements on the actual components that come from our sponsors that we identify and problem solve for them, and that's retained by the sponsors. So kind of have an arrangement where if you put your stuff on these cars and they donate it and you provide the engineering support for the teams, if we find something or we identify, issues with your software drivers or a hardware connection, then we just provide that information back to those companies.
Right. That's a huge advantage for them, right?
Yeah, right. And then I'd say the last area where there's some IP that's maybe more controlled by the organization in the Autonomous Challenge is just the maintenance and integration of the ADAS systems into these vehicles. So our cars are the fastest autonomous race cars in the world, and we wreck them a lot. So every car has been wrecked multiple times. We've had dozens of accidents, many of them at high speeds, some at speeds as high as 150 miles an hour. And every time they wreck, we rebuild them, we reconnect everything, we make adjustments and push the cars back out to run sometimes within 24 hours or less. And so there's a lot of knowledge that we're gaining around how can you operate the sophisticated technology that's needed in an autonomous vehicle, perception systems, radar systems, drive-by-wire systems, computers. How can you maintain it? How can you secure it and keep it from being virtually destroyed when you have high-speed collisions? And so that learning is being captured at the organization level, and we hope to share that with other motorsports industries, with automotive industry, work with other companies to help them build from our experiences.
It makes a lot of sense as far as how, all the stakeholders are able to benefit from this. And then the industry at large, is able to kind of progress exponentially because, like you said, you're getting perspectives from across different technology providers, but also across different teams that are making these AI drivers. And like you said, it's not like all one company's cars racing each other. It's across the board. You're getting kind of this diversity in thinking and development and all of that. So maybe you can walk us through almost, AI for dummies style, how the algorithm is making its choices when it comes to these quick decision making that it's, having to take on the roads.
All right. So I'll give you the version that I'm capable of giving, which is usually to government leaders or corporate folks. So the basics of the vehicle are like any other autonomous vehicle. We have I like to think of it as different senses that exist that a human has, right? So, because what you're trying to do is recreate the abilities of a human driver, in our case, a human race car driver. So the obvious one is sight, right? And that's referred to as perception in the autonomous vehicle lingo. And for perception, you want to have different, you want to have sensor fusion. You want to have different types of sensing so that you get it right. So on our vehicles, and not on every autonomous vehicle, there's a debate about which ones you need and which ones you don't. In our case, we loaded the cars up with everything. So we've got 3 LiDARs, 3 radars, 6 cameras or optical. I would put like GPS, GNSS into the sensing world a little bit because it's kind of telling you where your location is. And so you've got that data being collected in real time. Then the second, kind of sense is the ability is sort of movement, which is your steering and your braking. That's all handled through a drive-by-wire system, which again, many modern vehicles are already running drive-by-wire. It just, in this case, there's nobody making any turn to the steering. So that comes from a company, Schaeffler. I should have said on the perception systems, we use radars from Conti, LiDARs from Luminar. We're still looking actually for an optical or camera sponsor. GPS, we use a company called VectorNav. Yeah, GPS, we use a company called VectorNav. And then the drive-by-wire is a German company, Schaeffler. And then all that information, feeds back sort of through a central nervous system, if you will, which has a lot more components to it than I have time to go into each one of them. But there's a lot of these subsystems and wiring and routing and switch gear from Cisco. It all gets into a central computer, which comes from a company, D-Space. And it's basically a supercomputer on board the car that's got a beefy GPU, CPU, a lot of capabilities. It's not a supercomputer you're going to find in a research lab, but it's stronger than your average desktop or laptop.
What's the footprint of the supercomputer?
It's a box that's probably 1 foot by 1 foot cube.
Okay. Maybe like 2 shoe boxes. Almost.
Yeah, maybe 2. Yeah. Between 2 shoe boxes or 4 shoe boxes. I'd say it's a foot by a foot by a foot. I'm probably getting it wrong a little bit, but
okay.
It's called the D-Space Altera unit. So if anyone wants to look it up, you can find information on it. So that's all fed. And then that's like the brains of the human, right? That's where the capabilities are. But what trains and informs that brain is then the algorithms built by these teams. And every car is exactly the same. So they're all getting the same perception. They're all getting the same, they all have the same movement. They all have the same brains.
Teams are just competing on the software side, the driver, like you said.
I guess another sense you might think of is like this sense of hearing, or even just our ability to communicate with one another. So there's like a Cisco wireless communication system that allow the cars to communicate back to the pits, to race control, to one another. Now, the teams have no ability to remote control the vehicle, but they still want to see that data so they can understand what's happening and make improvements. So, I think what we're working on is part of the algorithm that's not so much the level 5 plan for driving anywhere under any circumstances, because we don't expect anybody to come running out onto the track. We don't have stoplights, and we don't have intersections where you have to make decisions. So really, they're focusing on building algorithms that can make decisions very quickly with incredibly low latency, because when you're traveling at 150, 170 miles an hour, and the other vehicle that you're encountering is traveling at similar speeds. Now, they're going in the same direction right now. They're not coming at each other yet, but they're going in the same direction. That you're talking about really, really high speed, high throughput decision making. And so, I don't think it's nothing I can get into. You'd really have to talk to individual teams, and they're pretty close kimono about it, that they, how they build those algorithms up and what they stress, and whether they use more LiDAR versus, more GPS versus other information is kind of that's sort of in the secret sauce. But what we're doing is empowering them to make those decisions, but trying to use hardware and software systems that are in the commercial space, so that we also get the benefit of understanding the durability and the functionality and do these systems actually have the low latency that they claim, or that the engineers believe they have. Because in some cases, it's not so much that a company is going to produce a product that they intentionally overhype, right? Maybe that happens in some cases, but I think in automotive and autonomous, I don't think that's really what anyone's out there to do. But they may not have actually been able to test it, like in a modeling simulator. And in theory, based on the components they're using and the engineers that built it, it should be able to do this under these circumstances. But until you put it out there, it's hard to validate that actually works. And so that's what we're doing.
And so you've mentioned a few times kind of the processing and storage side as well of, the computing. What kind of challenges have you seen over the last couple of years when it comes to that, and how people are advancing that side of things? Because I think that's huge when it comes to all of how this technology is progressing so quickly. Yeah.
So I again, we have the luxury that we are building this test platform with like everything you could want, but not everything that anybody, not anything that anybody could afford in a future autonomous vehicle, right? So you can't put all these systems into a car. The cars are, we estimate these cars, if you had to buy,
I appreciate you being real about that,
Right. If you had to buy everything on this vehicle that's part of the autonomous stack, not just the race car itself, you're looking at maybe $500,000 to $700,000 worth of stuff.
Wow.
So it's a $1.2 million car essentially, with the race car plus all the autonomous
What a magical
stack.
Playground for these university students.
Yeah. So what we're learning from that, though, is the understanding from a computing standpoint of just how much data an autonomous vehicle can throw off. And so, like, if a team runs, to put it in perspective, I was talking to somebody who, works with NASCAR, and they're also a vendor for us. And NASCAR has a lot of data collection nowadays on their vehicles. And they were saying that when we run when we have one car running for 20, 30 laps, something like that, the amount of data that is being generated, around 3 terabytes or more, is equivalent to the entire season of all the NASCARs operating, together. Now, do you need all that data? Is all that data essential? Is all that data useful? We're collecting it because our teams are trying to collect everything, right? But in theory, you can filter some of that out. But it does tell us that, like, it's unrealistic to see a future where you're going to be able to handle all of that computational storage on the vehicle. And so that's why we've partnered with AWS to think about cloud. And we don't right now have like any type of decision making in the cloud. We don't even have any real time, cloud integration yet. But I think inevitably it's going to be this challenge of how do you not overbuild the cars so that you can keep the cost manageable, so we can get this technology out there, and at the same time filter through which data do you actually need to collect, so we're not just filling up servers for the sake of filling up servers, because it's not good for the environment. It kind of defeats the purpose of all of us moving to connected and sustainable cars if we're generating so much data that we then have to run servers with more electricity.
Exactly.
So I think that, you've got to get to the point where you can manage the data in a sustainable way, frankly, and sustainable not just environmentally, but just sustainable in terms of like what anybody could afford and what you actually need to store. So I don't think we're contributing too much to that yet, but I think it's on our minds and our teams are aware of it. And we definitely have also figured out how to like quickly get data off of a vehicle into the team to redo something on their algorithm, put it back on the vehicle and test it. I've got to believe we're doing that faster than anybody in the world, because I don't think that they're making like on the fly adjustments to the algorithms of a Waymo car or a cruise car. Nor should they be. I'm not suggesting that, but in our case,
we'll have to interview Waymo next and let you know.
Yeah, ask them. But when you're in like this competitive motorsports environment, they're making adjustments, very, very quickly. And to do that, you also have to have a lot of computational abilities.
Of course. And I also appreciate that you're bringing up the kind of reasonable sustainability that people should be targeting and developing these things. Like you said, there's so many aspects to that, not just the environmental impact, but what's accessible, affordable, realistic for this actually to grow, and for more people to be able to use it in the applications we imagine, kind of the dream applications to make societies more efficient and that sort of thing.
Yeah.
When thinking about the some of the applications you mentioned, like trucking or emergency kind of transportation, how do you see, and I understand we don't have all the answers yet, right? But in your experience,
play out? Yeah.
Well, yeah, just the transition from, what we have on the roads now to, you mentioned these being able to drive and kind of seemingly harmoniously with human drivers on the road and that sort of thing. I guess I always imagine when I think about autonomous vehicles, high-speed autonomous vehicles on the road, there would be a separate track for them or something, but obviously that would be a logistical nightmare. But how do you kind of imagine that playing out? Yeah.
Yeah, and maybe there could be, it might be just, or separate hours or like an HOV lane.
Yeah, maybe just a different lane.
First of all, I think what we're already seeing and what we'll see more of, and what I hope some of our teams and the work we're doing can contribute to is the adoption of level 4 automation, where you still have a human driver, you still have a human very much in the loop, able to take over the wheel at any time. But when we're driving on the highway, whether it's at night or with odd weather conditions or even just at higher speeds, increasingly we're starting to see technologies that can help you with lane assistance, help you detect if there's something coming up behind you, so on and so forth. So that can and should and is transitioning to this kind of level 4 automation environment in which we can get on the highway. We can be going at high speeds. We can put it into this kind of self-driving mode. And frankly, in my opinion, if done right, it's probably going to be better, safer, more effective than you or I driving under those conditions. If nothing else, the kind of 360-degree perception is a huge advantage. And then what we're trying to build out is what happens when there's a quick decision that has to be made. Does the human have to hit the brake quickly, take over and make that decision, which you always have that option? Or are these systems going to be capable of making some of those decisions or even recommending a decision to the driver by kind of showing them what the path is being recommended, and the driver can agree or disagree to manage those types of situations. So I think that's what's going to happen first. And then, eventually when you've got enough data and you feel confident, you can begin to take that human even further out of the loop. This could be like truck drivers that are more like a pilot in a plane that's in autopilot, right, mode. So, the truck driver may still need to get out of the depot, onto the highway, into a lane, that's a long stretch, put it into this kind of self-driving mode, and then maybe they can check out more significantly. And then eventually, yes, you're eventually going to take that driver completely out of the loop. And maybe they're only there to take over when they need to pull off and park at a depot, which can oddly enough be even more challenging sometimes than operating on the highway at a high speed. And then I think this kind of question about high speed, like higher speeds, which we have in places like Germany on the Autobahn. One of our sponsors, Continental, I was asking him, do you guys test your radars at speeds as high as our race cars? And his answer was, yeah, we do, because in Germany, people drive at 150 miles an hour on the highway. So I think, there's something to be said about getting these systems to be not only effective, but reliable at extreme high speeds, because at that point, you are going to speed up the economy. You're going to improve people's ability to get from, say, Indianapolis to Chicago in, a shorter period of time. And I do think that is going to also come with, back to the conversation we had about government and what's their role, that is probably going to come with building highways in a different way. That is going to come with, at the very least, having infrastructure along those highways that is more robust than we have today.
Right. It needs to be able to support it.
You're probably going to need additional safety systems, additional sensors, additional information. Also, because not every vehicle on the highway is going to be one of these autonomous high-speed
I think
vehicles.
That's the thing that seems most challenging, and also for a lot of people to wrap their heads around, is that transition time when it's a hybrid and there's a little bit of everything on the road,
Yeah, no, I don't know what that looks like, but I also know that we've lived in lots of different eras where the vehicles are wildly different in their capabilities.
Of course.
I guess at one point there was, horse and carriage and cars fighting for space on the road at the same time. So maybe it's a little bit more like that.
My Ford Ranger doesn't want to go above 70, and that's an issue sometimes on the highways here. So.
Yeah, that's right. Another thing I think that we're trying to do that is important with this whole effort is create a pool of talent that can figure this stuff out. So we're not going to solve all these problems in the next 5 years. Everyone's in a hurry to get automation commercialized in some way where people can say, okay, it's here, it's real, it's happening. I would argue we're already there. I think there's plenty of examples of autonomous vehicles that are operating in real world use cases, adding value, potentially saving lives, certainly creating more efficiency. So in some ways, it's already here, it's already real. But the national, talking heads and media probably still feels like it's not real enough. So I don't know if that's going to be 5 years from now or 8 years from now that we've reached that tipping point. But what I can tell you is that it's not like, okay, we've reached that tipping point, now we can declare victory and be done with this. You're talking about the next 100 years, the next century of this kind of innovation, and eventually the cars will not just drive themselves, but maybe they're going to be flying and so on and so forth. So for us, getting a group of the best and brightest minds from around the world, from top research universities in the United States and Asia and Europe, working on largely PhD students that are in their early 20s, some younger, some are high ability undergrads, to focus on this challenge of high-speed automation, to do it in a way that's very collegial, to build relationships with other students around the world. They're going to form companies. They're going to become professors. They're going to work in this space and work on this challenge, into their careers. And, I'm not saying it's the same thing as, the space race and the effort that was made around that, but there's an element of that at play here, which is creating this cohort of really talented, capable, motivated people, men and women that want to work on this challenge. Because honestly, some of the things that people thought were completely impossible, that you simply could not get autonomous vehicles to do, or couldn't get them to do reliably, or couldn't get more than one of them to do. In 2 years, 2.5 years, these teams have proven that you can. Yeah, they are doing it. So I think that's a big contribution, is this need for talent and people who are going to then, over the next 20, 30 years, solve these problems, and for us to create a launching pad for that is, I think, really the contribution Indy Autonomous Challenge is trying to make. We're not going to solve those problems. We're trying to train the people that will solve those problems.
Absolutely. And do you imagine, you've spoken a little bit about kind of, the growth that you've had over the last few years and expanding overseas and this type of thing.
Yeah.
Do you see, when it comes to the growth of your organization, do you imagine a future where you guys have spin-off initiatives where it is like this supporting infrastructure, like challenging university students and the next generation of talent to take on, all the things that go around, like we just discussed, the legislation, that
broad. Yeah.
Or not so much, but any of the kind of accessory, elements to what you're focused on right now, or do you really see it streamlined on, where the platform's at?
I think we want to focus on high speed automation and stay in that lane. That does mean, though, as we transition from ovals to road courses, we are going to have to think about the infrastructure. We already do work with Cisco and others to think about the infrastructure at our tracks to allow this to happen. And so you start to think about how that translates to infrastructure on public roads, and what that means to work with, departments of transportation at the national or state or international levels. Yes, I think those are things we can and will start to get into. And then I think the other thing that inevitably we will do, and I don't know whether the organization in the Autonomous Challenge will, try to structure this as much as it's going to happen naturally, and it already is the spin outs and spin ups that are happening around our team. So we have a company called Drive Blocks that was formed by participants of the Technical University of Munich team. There's a company called Autonomous that was created by students from the University of Auburn and the Polytechnic of Milan team. I expect there'll be more spin outs and companies that try to commercialize some of the learnings and some of the innovations that have been honed within the Indy Autonomous Challenge. I hope that what we can do, though, is, we know DARPA did the same thing. However, when DARPA was finished, I shouldn't say DARPA was finished, when those two challenges, 2004, 2005 challenges were finished, that you saw a lot of the individuals and the teams and the companies kind of scatter, go and work on their own things, and then try to raise money and bring those into the marketplace. I do hope that we can create more of a collegial, collaborative, safe space environment, network approach among the individuals, the teams, the sponsors. And so I'm hopeful that we can continue to provide that type of platform. A lot of people ask, okay, does this inevitably look like some type of professional autonomous racing series that looks more like an IndyCar or Formula One? And my answer has always been the same. It's like, no, we want to partner with the Indy cars and the Formula Ones to maybe transition some of this technology into those cars, so that human-driven race cars can go faster and be safer.
But this is an innovation platform. Yeah.
This is an innovation platform. It's not an entertainment platform. It has an entertainment value. It has a huge marketing value. But that marketing value is not, intentional as much as it is just the result of people are interested in bright minds doing new and creative things. So, we're not trying to figure out how to create some crossover sponsorship with an EDM show or something like that from a marketing standpoint. We're focused on the innovation platform.
I love that. And I think, the focus on research is so interesting. And like you said, is still able to connect to all these other spheres and fields and, parts of the industry. So we're almost out of time. I want to be conscientious of your time here. I really appreciate, I know you're busy and you've given us so much to think about. My mind's spinning about all the other, folks we can interview and connect with to follow up this conversation, because I feel like we just kind of scratched the surface with you here. So thank you so much for the introduction, to a lot of these things for our audience. And I just want to wrap up with a few more personal questions that we do at the end of a lot of our interviews. So what's something outside of technology that's inspiring you right now?
My kids. I've got 4 kids, a 9-year-old, but I've got 3 under 3. So almost 3-year-old, 1.5-year-old.
How do you even have time for this now?
Yeah, everybody jokes that there's a new Mitchell baby every time we're going to run a race, because I've had a baby usually 1 month before a race, the last 3 years now.
Wow.
So that's just how the universe plays things out. It was not intentional. So I learn a lot from, I'm inspired and learn a lot from them. You kind of have to when you're in that phase of life where you're working hard and you also are trying to raise a family. You sort of look to the kids for inspiration. And, and for me, it's fun to sometimes think about, like, are these kids, when they're like teenagers, are they actually going to learn to drive a car, or am I just going to put them in a pod and they'll go to grandma's that way, or I'll say, take them to basketball practice, and it just takes them to basketball practice. So I maybe it sounds kind of hokey, but I think being around young children is in and of itself kind of an inspiring thing.
Absolutely. And last but not least, what would you say is on your personal bill of materials? You've given us an in-depth, look at some of the line items on the autonomous vehicles BOM, but we'd love to hear what's on your BOM to get you through life, get you through the day, get you through a challenge.
So I've got, I have this like blood sugar challenge where I'm not diabetic, but I've got called like hypoglycemia. So I have to snack all the time. And if you know anybody that's around me, like, I will be in a meeting, could be with anybody.
They're like, Paul's got the snacks if anyone's hungry.
And I will pull out an apple and peanuts or this, a lot of protein bars and stuff. So,
that's great. That's a new one. We haven't had that answer
My build
yet.
of materials is having to have snacks available all the time, because you never know when you need that
love it.
extra juice to get through the next hour.
Definitely. I think many of us can relate. So thank you so much for sharing. And again, thank you for the in-depth look at the Indy Challenge. And is there anything else you want to share? Yeah.
No, I was just thinking in my head, I'm thinking like, my favorite, I'm inspired by little kids and I need snacks. So maybe those are.
On that note, no, but the rest of the interview is so advanced that it makes up,
right,
it's
good.
the equilibrium. Thanks
Very
so
good.
much, Paul.
Right. Thank you very much. Take care.
Thank you, Paul, for sharing all your knowledge about the Indy Autonomous Challenge and its contributions to AI. I don't know about you, but I had never thought about the role of motorsports in AI innovation. If you're eager to learn more, they recently started their very own podcast called The Inside Track, Our AI Future. It's available on all platforms. Once again, thank you for listening. I'm Magenta Strongheart, and this is The BOM. If you like The BOM, don't forget to subscribe, rate, and share the show wherever you get your podcasts. You can follow Supplyframe and Hackaday on Instagram, Twitter, LinkedIn, YouTube, and Design Lab at Supplyframe Design Lab on Instagram and Twitter. The BOM is a Supplyframe podcast produced by me, Magenta Strongheart, and Ryan Tillotson. Written by Maggie Bowles and edited by Daniel Ferreira. Theme music is by Anna Hogbin, show art by Thomas Schneider, special thanks to Giovanni Salinas, Bruce Dominguez, Thomas Woodward, Jin Kumar, Jordan Clark, the entire Supplyframe team, and you, our wonderful listeners. I'm your host, Magenta Strongheart. See you next week.